So welcome back. This video is going to talk through polymers, but only from the bonding unit perspective. So really we're only going to be looking at addition polymers. Now this is relevant to both combined and triple science here. Okay, you could be asked about this for both. Triple scientists, obviously you need to know about condensation and natural polymers as well, but we will cover that in a different video. So addition polymers. Firstly, let's think about what a polymer actually is. Okay, so polymer, if we look at the word, crucially it has poly in it, and poly just means many. Okay, so if you see the word poly anywhere, poly means many. You could think polyamorous. Polyamorous means that you have lots of partners, okay? But poly means many. Now, polymers are they are long chain molecules made up of lots of small molecules. Now the important bit here is this bit, these small molecules, because they have a name as well. So the whole thing is called a polymer, the whole long chain thing is a polymer, okay? But these small molecules also have a name. Now, question for you, if I've got one of these as eyebrows, what's it called? You might have gone unibrow, but the one I'm looking for is monobrow in this case. Okay, that would be a monobrow, wouldn't it? It's a single brow. Mono means one. Okay, so mono is one. Now in this case, these small molecules, these single bits that make up the long chain, are going to be called monomers. Okay, so polymers are made up of monomers. Alright. If you see mono in science, it always means one. If you see uni in science, unicellular for example in biology, that also means one. Okay? So polymers, they're long chain molecules made up of lots of small molecules called monomers. Now, if we're going to think about addition polymers, which is obviously our title for a second, the monomer of an addition polymer always needs to be an alkene. An alkene. Now again, if you've done the organic chemistry unit, you'll be quite familiar with this, I hope, and you will know that alkenes have to have these, okay, so they have to have carbon-carbon double bonds in them. Without that, you cannot have an addition polymer. So you must always have an alkene as a monomer. Let's have a look then at some examples, or maybe we'll look at how to name them first. So the first one that we'll do is we will go for polyethene. Now that there is the name of the polymer. Okay, that's the polymer. The monomer for this is just the thing in the bracket. So in this case, the monomer would simply be, I'm not going to draw the bracket actually, the mono would just be one molecule of ethene. It's the bit in the bracket. Okay, the monomer goes inside the bracket like that. Now the reason I picked polyethene there is because polyethene is probably a really common one you could get asked about, and also really importantly, it's plastic bags. Okay, we have polyethene bags all the time. It's quite a common one that you'll see in everyday life. So let's have a go at drawing it then. Let's have a go at polymerizing it. Now the process of making polymers is called polymerization. Okay, so let's polymerize then ethene. So here's my monomer. Again, for those of you doing the organic chemistry unit, you need to be able to draw ethene, so I'd expect you to be able to draw it, but for now I've given it to you. There's ethene, okay, and we'll label it underneath. There's ethene. So if I want to polymerize ethene, you need to follow these rules every single time, and you will find it very hard to go wrong. So, first step, always break the double bond, like that. So I have a single bond in here. There's always a mark for this. That will be one mark there. Okay. Next bit, put these bonds, so 1, 2, 3, 4, in the same places there. Now you need something to join your monomer to other monomers, and that's going to be what we call trailing bonds here, like that. And then when we draw a polymer, we put brackets around it, like this, okay? Now, some of you will be looking at the screen and going, you're missing something really important. And I obviously am missing the H's that I need to put on, but you also need to make sure that you are putting an N here. N implies a certain number, so it could be 500, 400, 300, 1,000. It's the number of these repeating units in your polymer, okay? Now, not only do you need an N here, you also need N amounts of monomer, right? So if I have 500 monomers, I'll make 500 repeating units, and so on and so forth, okay? Now, you can draw this structure every single time for addition polymers. All of your additional polymers should look vaguely like that. Do not fall into the trap of putting 3 C's in the bracket. Not right, okay? You cannot do that. That would get you no marks, okay? Completely incorrect. You need to make sure you only have 2 C's in the bracket like this. Now all you've got to do now is transfer your groups across. So this H is going to go on there, this H is going to go on there, this H is going to go on there, and this H is going to go on there, like that. So what would be the name of this polymer? It would be polyethene. Those who've done the organic chemistry unit, be careful, don't fall into the trap of going, well, that's single bonded now, so that looks like ethane, and saying polyethane. It is not polyethane, it is polyethene. You name it after the monomer. Be careful with that. Okay. Right, let's look at another one. Let's this time look at this molecule. Okay, so hopefully triple scientists, if you've done this, you should be quite familiar with this, but this one is di meaning 2, chloro, and that's my chlorine, so I've got 2 chloros, ethene. That is dichloroethene. Okay. Now let's polymerize it. So what are my rules? What am I going to draw first? Okay, I'm going to have C, like that. I'm going to put my bonds on, like that. I'm going to put my trailing bonds on there. I'm going to put my brackets around it like that. And I'm going to have an N there like that. I also need an N there like that. All you've got to do now is move your groups across. So let's have a Cl there. Let's have a Cl there. Let's have a H there. And let's have a H there like that. Nice and easy. Okay, all we're doing is keeping the groups in the same places and moving them across like that. Right, let's go now for a slightly trickier one, and one that I see students get wrong all the time. Okay, so if you've done the organic chemistry unit, pause this video and draw me propene. If you haven't, I'm going to draw it with you. So propene it means it's an alkene again. It implies it's got this carbon-carbon double bond. Prop means 3 carbons. Now my advice at GCSE to my students is always to put the double bond at the end. Make it easy for yourself. That's obviously, it's not true. At A level you can have double bonds all over the place, but at GCSE you're only ever going to have 1 double bond, so just put it at the end of your molecule and make it easy. Now let's try and polymerize propene here. So if we polymerize it, first thing to do again, break the double bond. Put my bonds on, put my trailing bonds on, brackets around, N, do not forget the N, and N. There is a mark for that N, so do not forget it, really important. Now this one's a bit trickier at first glance, because you're thinking, oh, what on earth do I do? Where's this extra C go? And remember we said do not put 3 C's in the bracket. Don't do that. No, that's going to be wrong, okay? That's not going to get you any marks. So let's start to think about where we might put our groups. This H here is going to go there, like that, okay, just like it did before. This H here is going to go there, just like it did before. This H here is going to go here, just like it did before, which leaves us with this group here. Okay, so we've got a little group of atoms, haven't we? We've got C and 3 H's. So let's just shorten that to CH3, like that. And there you have polypropene, like that. Okay? Right, let's see if you can have a go at one then. Now again, if you've done the organic chemistry unit, pause it here and have a go at this yourself. But the one that I'm going to get you to do is butene. Okay, butene. So, butene, but means 4, or 4 carbons, so we've got a molecule that looks something like that. Now, organic chemists, remember, be careful, carbon can only have 4 bonds, so 1, 2, 3, 4, that's why there's only 2 hydrogens there. This is the carbon that students will get wrong all the time. They'll put an extra hydrogen here. 1, 2, 3, 4, count up your bonds, be careful. Right, let's polymerize butene then. So if we want to polymerize it, again, stick to those rules. Got to look like that. We need an N and we need an N. Now then, let's move our groups across. So I've got a H here that's going to go there. I've got a H there that's going to go there. I've got a H there that's going to go there. And then I've got this group, haven't I? Which is a bit of a bigger group this time. But again, we can simplify it. Now you can simplify it in 2 ways here, and if you've done this and you're marking it with me, right, let's see what you put. So I could go for, there's 2 C's and 5 H's, so I could go for C2H5. That would be absolutely fine. Okay, that would be polybutene. I could also go for CH2CH3, like that, and that would also be polybutene, like that. Okay, 2 different ways of doing it. Now, really important here, we are not going to talk about in this video the properties of polymers. We are going to talk about that in a different video where we discuss the differences between the properties of polymers and the properties of simple covalent molecules and the properties of ionic substances. This is just a video to show you how to draw addition polymers. So if you want that information, find the video that does that.